Welcome everyone. Thanks for taking time. I know it's lunchtime, so please enjoy your food. If you're eating your lunch, if you've had lunch before, hopefully enjoy that as well. As we get started, just a quick forward-looking statement here. This presentation is for informational purposes only, but we're excited to show you some really cool stuff pretty soon. And like this session and every other session coming up, you will get surveys in your apps to ensure that you fill those out so we can provide the best experience for you guys going forward as well. FinOps at scale, best practices for cost-efficient growth on Databricks. My name is Sadhana, Bala. I'm product manager here on Databricks, focused on cost management and cost observability.
Hi everyone, my name is Cody Davis. I lead a team of solutions architects in our digital native business and get to collaborate with our lovely product team on observability, warehousing, and a couple other areas. Definitely excited to talk to you all.
All right, so just to start, out of curiosity, last week, was anyone in San Diego at the FinOps conference by a show of hands? Okay, we have one who I know well. Greg's our product lead here as well.
Not a lot of people want to do two conferences back to back.
Yeah, San Diego had better weather than SF. But for those of you who don't know, the FinOps Foundation hosts a conference every year for FinOps practitioners. We actually learned at that conference that there is a huge population of FinOps practitioners globally. I think they quoted 85,000 individuals. So FinOps is something that you think about every day, we think about every day, and we want to cover best practices in that field in this session. For those of you who don't know, what is FinOps, Cloud Financial Operations? It's both a framework and a cultural practice that maximizes the business value of cloud technology. Here we're talking about, of course, Databricks, in a way that's driven by data in decision-making, and the end outcome is shared financial accountability through collaboration between both engineering, finance, and business teams. So this year was sort of Databricks' inaugural presence at the FinOps conference, and it's something we care deeply about and are excited to dive into this realm today. If you're if you're an account admin here on Databricks, maybe you've seen a step change in your usage on the platform through a curve like this, and this may not necessarily be a bad thing. Maybe what you're seeing is more users joining the platform, especially as you onboard different types of products. Maybe you're seeing more data flow through the platform as you're hooking up more ingestion connectors as well. More experiments, especially in the AI space. Your teams might be prototyping proof of concepts on the platform. And more migrations, especially if you're trying to centralize potentially Databricks as your primary jobs orchestrator, as an example. So we've heard from many of you and customers like you that while that growth is exciting and you're seeing a lot of value on your platform, there are scaling pains that you're facing. And what are some of these? One of them might be sort of incomplete cost allocation. You're having a hard time tying all your dollars back to particular teams, and that's making it hard to do fully loaded chargebacks. Maybe the growing admin burden to monitor hundreds of workspaces just becoming manually impossible to do, or with the new frontier of AI, understanding how to do FinOps for AI is a puzzle, and that's something we're figuring out as well. Maybe you're seeing an influx on sort of lower trust or less experienced users that may not be steeped in the cost optimization best practices, but they're able to do powerful things on the platform. And maybe at the end of the day, if someone's asking you, what is the total ROI you're getting on Databricks and which areas are you having positive unit economics, maybe you're having a hard time telling that story. So let's tackle those types of pain heads on through the FinOps framework. If you've seen this before, this is the classic framework from the FinOps Foundation. We'll break our session into 3 pillars here. So to start, inform. This is around we want to make sure you understand what data sources and reports you should look at to understand your cost and usage data deeply. We'll then talk about optimization. Beyond observability, how can you actually take actions to ensure that you're right-sizing your spend and getting the most performance for the least amount of dollars? And finally, we're talking about FinOps at scale here. So how do you actually imbue FinOps throughout the veins of your organization? So FinOps is everyone's job and not just something the central admin team has to manage.
So what does that look like more practically? Typically, we see within organizations to create this feedback loop of FinOps operations all the way from the top down. So this usually starts with an executive having control of a given budget, wanting to just know, understand, and be able to manage how are we doing on our budgets, how are we doing on our vendor contracts, how are we trending overall up or down, and where do we need to focus to optimize and manage our spend that may be running away. Those executives may then pass that question of where we need to focus, identify 1 to 3 initiatives and say, hey, I need you guys to be able to understand this area of usage and ask deeper questions to understand what's driving that usage, what's contributing to it, and is it correct. So they'll typically pass those questions down to the P&L leaders, typically middle management director level, that own specific business areas, use cases, and teams that own that usage to diagnose and find and manage those cost drivers. To ask questions like, for the specific team or environment, what is driving this cost? Where are things efficient? And where is spend not being managed well? How do I fix that? Those middle level managers that own these use cases and own the sort of outcomes for what is driving the data platform can then work with the engineering teams that actually build on top of Databricks to start to automate, optimize, and manage that usage, finding the root cause, figuring out how to fix it, and then how do we make sure this usage stays managed. So this feedback loop going from top down and then changing what the engineers do day to day to bubble up a better operational framework from the bottoms up is what we want to showcase today with the given tools that we have and what we have in the product and what we have in the broader ecosystem to complete this feedback loop. So staying true to Databricks' commitment to open source, we have a full spectrum of solutions that allow you to do this end-to-end feedback loop of observability. First level is obviously self-built. You can use all of the Databricks logs, the APIs, and the system tables to build your own custom solutions. So lots of customers like to do this. The benefit is that you can customize this to your heart's desire to do whatever you want. The downside to that is not everyone has the time, energy, and money to reinvent the wheel. These observability problems are all the same problems that we all in this room have. We would mostly rather one person solve a problem and then share that with the broader community. So that leads us to a really rich ecosystem of field and community built dashboards, frameworks, and assets that are built by SMEs and subject matter experts and then shared with everyone in the broader ecosystem. This helps validate, test metrics, but also keep innovation speed pretty high and keep the actual logic and frameworks open so that if you do want to customize something, you're customizing some of these tools based on battle-tested, hardened logic and not something you may be sort of building from scratch. A couple great examples of these we'll show are tools like our dashboards, like a warehouse advisor dashboard to manage warehouse performance, workflows advisor dashboards to optimize jobs, etc. Even further than that, last year we released our account usage dashboard that's a native tool dashboard in the product, and then the cost per query dashboard on Databricks SQL. This represents sort of a higher level of support from Databricks. These are tools built by Databricks people where the logic is validated, battle tested, and even supported by Databricks, but it's still open, still customizable if you want to extend those tools. And then of course, lastly, we offer native product integrations such as the system tables themselves, monitoring frameworks, as well as budgets that Sadhana will talk about as well. So we have a full gradient and suite of products that you can use in concert together to build your own observability solution for your platform. So we'll showcase a couple demos here in both of these areas, as well as some just customer stories.
Awesome. Start with pillar 1, inform. Again, this is all about observability. How do you get a good sense of what you're spending on, where you're spending that, and how that spend is pacing over time? The key takeaway here for you is cost observability starts with system tables. Hopefully that's something you're familiar with already. If not, system tables are delta tables that store all the operational activity across your account. In particular, the system billing schema provides high granularity and low latency visibility into all of the billable usage on your platform. And when you double click into that table, you'll see there are a couple of key fields that you want to be aware of as you're building your cost reports. So some of these fields, billing origin product, that will give you the ability to tie every dollar back to the originating product or SKU that the spend sort of emanates from. Usage metadata, that will give you the ability to tie the dollar back to the particular object ID, the job ID, maybe the warehouse ID, where that spend emits from. Identity metadata, that field will give you the ability to actually tie the dollars back to the responsible principal, whether it's a user principal or a service principal. And then of course, FinOps best friend tags. The custom tags field will give you the ability to slice and dice and organize your spend based off tags that you apply based on your business taxonomy. We announced this last week at the FinOps conference, but we're excited to announce a private preview of the billing usage data in the focus schema. The focus schema is a common data model that will make it possible for you to harmonize your Databricks billing logs with other logs and other types of vendors you may manage as your FinOps practice. Cody spoke with this, but last year we launched, and this is available today in the account console, an AI BI usage dashboard. This is built on top of the system tables I just mentioned, and this provides you with a high-level interface that allows you to do a couple things. Get an overview of the overall usage across your account, across workspaces, across SKUs, use tags as a top-level filter, and identify what the top billable objects might be. Maybe what are your top 10 warehouses that are contributing to your spend. But Cody has a lot to share on what's coming up in this realm.
Absolutely. So just curious, before we dive into the new version of the dashboard, who has actually used this initial V1 usage dashboard so far? Roughly half. Okay, cool. Great distribution. So in this initial version, we realized that it's a really great start to be able to identify, manage, and see usage from a high level, as well as do some basic tag filtering and top spending. Perfect start, but doesn't quite get us that full feedback loop of going from top down executive budgeting down to IC level operations and back up. So we talked with customers and really identified 3 key areas to complete that feedback. So in this new usage dashboard 2.0 that we'll be releasing soon and showing today in a demo here in a minute, we extend version 1 to start with high level spend and then drill into that. So we want to go deeper to be able to track key actions in the dashboard, identify key drivers and objects, as well as figuring out who owns specific objects that's driving runaway spend or maybe unmanaged usage, connect that down to the individual contributor, and then bubble that back up to create that feedback loop. So with this new framework, you're able to utilize tags to do chargebacks and P&L management. So you can create a policy layer to make sure all usage is tagged by team or use case or environment or budget or however you want to manage your spend with the way that fits your business. And then you can additionally find usage that is not compliant to those tags. So this is what I like to call ghost usage, but this is just unmanaged usage where you don't know what it's for, you don't know if it's driving value. You want to be able to find and fix that and manage that very quickly. And this is what's going to ultimately create the feedback loop to start to take action from top-down exec reporting to finding untagged usage, managing that, and then creating actions such as policy alerts, setting proactive budgets that Sadhana will talk about, and then digging into specific engineering tactical next steps that you could take, like right-sizing a SQL warehouse, or making a job smaller, or just tagging metadata so you know where this usage is going if you want to tag it to maybe a revenue-generating use case that you want to manage. So let's take this high-level framework and apply it to the actual new usage dashboard. So I'll go over here.
Yeah.
All right. So this is V2 of the usage dashboard. The first thing you'll notice is we now have tabs in AI BI dashboards. So this really helps open up that flow to go from high-level spend down to individual detailed level. So let's say I'm an executive at Databricks, theoretically. I want to be able to manage my spend. I can see my top level spend is this much over a 14-week period. I can even forecast spend in this new version. So we utilize AI forecast natively to be able to forecast usage to what I want to forecast. Let's say I want to see next week's usage or next month's usage. I can even subscribe to this dashboard and trigger alerts on this as an executive to see maybe, hey, if forecast usage goes above a certain amount, I want to get an alert, I want to know, I want to proactively get ahead of that before it becomes actual realized usage. So you can definitely do that here and see that all in one trend. So as an executive at Databricks, I can clearly see SQL, model serving, vector search, clean rooms, all of these are top drivers of spend, and all of these have been increasing pretty recently. So this big chunk of green and pink usage is sort of kind of scaring me a little bit as an executive. I want to see what's going on with this because my model serving SQL and especially my vector search usage has started small and very recently increased week over week. And in the dashboard, if you manage your business and you want to see monthly spend, daily spend, you can dynamically toggle that with this new global filter that lets you see the entire dashboard by the time frame that you want. So here we're looking at weekly, and our weekly spend is increasing quite a bit. And we're seeing it's coming all from, really this top big workspace here, but it does trickle down into other workspaces throughout. So I want to be able to dig into who owns that, who do I need to go to, and what initiatives do I need to create to manage and either make sure that spend is reasonable and planned for, or turn it off and make sure it doesn't happen again in a non-managed way. And this is a very quick, as an executive, top-level summary where I can see quickly, period over period, what my increases are. So I can see very quickly that SQL usage has been increasing quite a bit, as well as model serving and vector search. So I will then pass that over down maybe to a couple direct reports to identify and diagnose the root cause of that. So let's actually do that. We'll go into this new deeper dive usage analysis tab. As maybe an engineering manager or engineering director that owns maybe a portfolio of teams or a portfolio of business use cases, I can then search all of my usage by any tag filter. So this was in usage v1, but this extends that functionality even further to be able to do really two key actions here. To be able to track usage that is managed and categorized by team, use case, environment, whatever it may be, and also very quickly find and detect and manage my untracked usage. So you can see very quickly, this is a demo environment, so unsurprising, but we have a huge problem of not tagged or usage that isn't tagged by team. So I do not know who owns this not tagged usage, and I really want to be able to quickly find out what that usage is, who owns it, so that I can properly categorize it and fix it. And then as I start to do this with my engineers and NICs that work under me in these various teams, I can track my match rate over time. So we want to see this improve. So as you begin to inject this into your operations, you can track the improvement and compliance to your tagging policies over time. And you can, of course, save this dashboard to basically snapshot all the tags that you use. So here, I can scroll down even further. I have a similar view where I can track my usage over time and by workspace or any other grouping that I want to be able to look at that for my specific tagging area. So I can see 5% of my usage is tagged. We have a huge problem of a massive explosion of usage of not tagged usage. So I want to diagnose, find, and fix that. And we have a team, our data platform team. It looks like they have some brand new usage, but it's exploded very quickly just in the last week. And I can quickly see that, and I want to be able to go to that team and make sure they're budgeting, planning, and optimizing the usage. Maybe they're onboarding a new use case and they need to right-size things. I can quickly get ahead of that here. Let's say you don't have a really mature tagging process yet. You just want to know who's using what tags and sort of get ahead on things on a system that already exists. We added this tag popularity section that just lets you figure out very quickly what tags are being used. So this is a common feature that customers have asked for. I'm just saying, what are my used tags? I don't know where to start. This shows you that budget policy, serving endpoint, team are great places to start, and you can continue to add from there. So now that I can manage usage by tag to basically form fit my ops framework to my organization, I can then drill even deeper and go down that feedback loop. And let's say we can look at our team and find the specific, what we call billable objects. Maybe that's a SQL warehouse, a job, a cluster. I can look for usage that is tagged or isn't tagged, but I can very quickly just go to this heat map and see that SQL and vector search is a problem. There's a lot of spend here. It's actively been used in the last 30 days. I want to be able to scroll down here and see my top drivers of that spend. So here, my top driver of spend that is not tagged, not managed, is a SQL warehouse. So I can scroll over and see all the information about it. I can see that my next top driver of spend is a properly managed SQL warehouse, so that's good. But this is a big problem. So what do I do with that? How do I find out who owns it? What do I do to fix it? Well, if I have permissions to that SQL warehouse, I can actually just go in straight from the dashboard, directly click into this warehouse, I can quickly see who owns it, who created it. I can even just tag that usage directly here. So I can fix my untagged usage, and categorize it into a data platform use case. So now I've gone through this entire feedback loop in a matter of 3 minutes, and that used to take teams quite a bit longer, and used to have to ruffle through that, and it would be pretty difficult. So this is a really, really helpful feature functionality that customers have asked for quite a bit here. So this is a great end-to-end starting point of that end-to-end feedback loop. A couple additional things here. We have plenty of new preview features that are toggleable here. The most popular ask and example is the ability to either use list prices in this, or actually use our new preview account prices table that includes your actual contracted rates, as well as you can actually override and simulate your own discounts or your own prices in this override spot right here as well. So if you're like working on a new deal with Databricks and you want to figure out what spend might be, do some budgeting simulation, you can override and say, new SQL discount 0.1, whatever that may be. So lots of really great functionality there. But yeah, so now we can then go from high level executive overview, figure out forecasted usage, to a couple initiatives that I need to focus on, where engineering leaders can then drill into that, manage usage by team, and then the specific engineers and ICs can then find specific assets that need to be fixed and managed. And this sets us up for an end-to-end feedback loop for that sort of section 1 of the inform phase of things. So now that we know what our usage is, who owns it, who to go yell at, let's talk about what to do next to fix things.
Oh, thanks, Cody. Yeah, we're excited to get that in your hands soon, so stay tuned for updates there. Yeah, so section 2, optimize. Now you know where you need to figure out, now you know where to right-size your spend. The question is, how do you do it? What are the particular objects that you want to have more control over? We'll talk through sort of 3 examples of real-life dashboards that let you do this across 3 different product lines. But just to start, it's important to remember that optimization, we often talk about cost optimization, but really you can't think of cost without performance on the other side of the house. And it's not always a trade-off between price and performance, of course, but even as FinOps practitioners, you want to be aware of the different technical requirements of your workloads, the workloads that you're looking to optimize. And those technical requirements are often driven by the business use case of that workload. For example, can this workload be tolerant to fault and disruptions? If yes, then there's a lot of different types of instances you may want to use, like spot instances to manage costs. If no, then you may have less flexibility there. What is the type of concurrency requirements on your workload? Like how many simultaneous users might you expect to hit the same application or the warehouse? And as another example, are there sort of tight SLAs and SLOs around the overall execution time end-to-end for your workload? If yes, you may have less flexibility there, but if not, that kind of gives you more options for optimization levers. The most disciplined customers take a top-down approach to cost and performance optimization. Often the low-hanging fruit here is with waste reduction. Really, this is identifying objects that could be decommissioned. The refresh frequency of these objects could be reduced as well, because the business value just isn't justifying the cost that these workloads are emitting. Okay, maybe you prune those objects, and what you're left with is really critical business use cases on the platform. The next step is then right-sizing, and this kind of goes back to the previous slide. How do you actually align the compute and the instance choices that you're selecting in your configuration to best align with the technical requirements based off the use case? Once that's done, of course, looking at the data and code layer is important as well. With data based off the access and the query patterns on the data tables you're looking to optimize, are there more efficient partitions and clustering techniques that you can use? And with code, how do you best structure that code so it's efficient on your engine? As a bonus tip, do try the optimize method on the Databricks assistant. That will actually give you prepackaged optimized code based off the query that you've written. And this isn't just theory. We've seen customers do this successfully through a data-driven FinOps lens. This is a real-world case study of a customer that was able to achieve actually millions in annual savings through leveraging system tables for optimization, identification, and prioritization. How are they able to do that? Well, like I said, waste reduction usually is the low-hanging fruit here. they actually realized hundreds and thousands of spend came from legacy pipelines that were running post a migration that were no longer actually useful in terms of the data it was outputting. They also saw some pockets of optimization from turning off Photon in non-production environments. Photon's really great for rapid, fast performance execution, but maybe in a non-production environment, you don't really need that type of SLA or SLO requirement. They also saw opportunities for cost reduction from improving auto-termination rules on a cluster. They had clusters that had over hundreds of minutes of auto-termination as a policy. So these clusters were actually up, even though they weren't running workloads or were of value. And sort of last, and this is actually this is a favorite cost-saving technique that we often try to sort of teach our customers is for your job workloads, migrating them from all-purpose clusters to jobs compute to take advantage of both better pricing on jobs, but also so jobs compute scale up and down based off the actual workload needs.
Awesome. So in the demo, we showed how to find usage that may be large, overspending. I want to cover now 3 examples that as an SA leader, I am talking to customers all the time about these 3 examples on once you find usage that may be high, what do you do? What do you do about that? How do you technically solve that problem? And the top 3 problem areas and solutions that we have that are open source and we'll provide at the end of this presentation are jobs. So how do we right size and manage all of our jobs across our ecosystem? We may have thousands, tens of thousands of jobs. How do we manage that at scale? The second one is SQL warehouse sizing and performance management. And the third one is really table health and storage management as well. So speaking to example 1, you can utilize system tables, and we have an open source dashboard built by our field engineering experts that utilize these system tables out of the box to do things like calculate cost per job, manage job SLAs and runtimes. So find your jobs that are kind of above your SLAs that you need to find and fix. Look at cost per job, cost per owner of a job. So going back to that who owns it scenario, how do I know who's spending what on the platform? Who do I go to right size spend? Most interestingly, nearly all customers want to know 2 things. What are their top jobs that are maybe under or oversized? So both can contribute to overspend. If your jobs are undersized, then your compute can be running much, much longer than it would need to if you right-size your compute. This is typically very unintuitive for customers. They think if my compute is smaller, then I'm spending less money, but that is not always the case. So it's good to see both sides. The other side of that coin that's equally, if not more popular, is how do I find my jobs at scale that are not utilizing all the compute they have? It's very easy because Databricks is easy to use. You can create a cluster and run a job, put it in production, and not actually realize you may need like half the compute that you actually deployed, or even less. So this dashboard is a out-of-the-box solution accelerator built by our field expert team, just to help find that Pareto analysis of your top over and undersized jobs, and another example of top cost by Databricks runtime. That's a really common question for customers that have old runtimes that are kind of aging out. Those often cause performance problems over time as data increases. If you don't keep up with the runtimes of DBR, maybe you have some runtimes that are 3-4 years old, that can actually end up costing you more than helping you. And it may be worth the migration effort to the newer runtimes. So this helps identify and fix some of those key issues. Example number 2, my personal favorite, is SQL warehousing. So SQL warehousing, relatively newer on Databricks. By that I mean 4 years or so, but now has really gained traction all throughout the company, all throughout the industry. And we've spent the last couple years really building open and robust tools to manage warehouse performance. So you can utilize newer system tables such as the compute, the warehouses system table, query history, and warehouse scaling system table to manage warehouse performance, so actually measure SLA for one or many warehouses, and then identify scaling trends. So does your warehouse need to scale more for concurrency, or does it need a larger compute size? So that question, although it seems simple, is often hard to answer without a top-down view of what your workload shape looks like. And this Warehouse Advisor dashboard provides that out of the box. Lastly, doing that sort of top-down approach that Sadhana has mentioned, it's very important in warehousing because otherwise you could just be endlessly chasing queries that look expensive that don't actually help fix your warehouse level problems. But we do have a section that allows you to quickly click into the common issues such as high queuing time, high result fetch time, disk spillage, to find and fix bad queries very, very quickly from a top-down lens. So a very popular dashboard. And then the third example is table optimization and storage. So I'm sure most of you here have probably a good chunk of tables that you don't even know if anyone uses them, yet jobs are writing to them. How much is that costing? We have open tools where customers have either built themselves or extended our subject matter expert built dashboards to identify stale tables. Maybe there's jobs writing to tables, but they haven't been read from in over 6 months. Well, we can delete those. That's wasting storage, that's wasting ETL capability. Maybe we want to actually charge back the storage of those tables and calculate cost per access. Well, we can utilize those lineage tables in Databricks as well as our other system tables to do some of that analysis. And so these are two examples of dashboards that we have available open to be able to do those things. And those are really the three most popular use cases that I see, getting to the optimized section of finding that bloated spend and then fixing that in the actual product itself. And all of these are open solutions that you can extend yourself as well.
Okay, wrapping it up, this is our third pillar, operate. So again, going back to the framework, this is actually great. You know this data is available. There are dashboards you can use to optimize the spend. But as the user base on your platform is growing, how do you actually build this continuous sort of feedback mechanism loop for FinOps, and what are tools that you can use to actually automate that? We'll speak to one of the favorites, and by show of hands, has anyone used the budget tool on Databricks before? It's in the account console. It's maybe fewer. It's tucked away in the account console. We're working on that as well. But budgets allow you to define and share alerts when spend has actually exceeded a predefined budget threshold that you set. Those alerts can be shared with downstream teams, with your management team, whoever is relevant. And those budgets can be set both at the account level, workspace level, or at a combination of tags. And based on your feedback, we're excited to announce a couple of enhancements coming to the budget tool. One will be richer visualization that will allow you to more quickly identify what the actual drivers of the budget overrun are, more configurable thresholds to define custom alerts and get alerts earlier, based on what level of noise you find acceptable, and an improved tag search experience. We know customers love using tags to identify how to define a budget, and improving that experience to show you what tags are most popular and high usage will allow you to accomplish that better. Taking a step back, one of the themes we hear often is the idea of shifting left on FinOps. And what does that mean? Traditionally, the personas that you think of as being responsible for FinOps are individuals like this, maybe finance, management, IT asset management, especially for SaaS licenses. But really on Databricks, as you know, the spend generation starts far upstream of that. Maybe BI analysts to ML engineers, depending on what products you're using. And the idea of shifting left on FinOps is empowering those individuals to have access to that data and ensure that they comply with those cost governance from the get-go as well. How do you do that? On the transparency front, we talked about budget alerts as a way to accomplish that, but also the system tables that I mentioned, those are designed to be as widely shared or not shared as you desire. They're using the UC catalog and permissions there. You can share those tables widely. We have examples of customers that make those cost dashboards that Cody demoed accessible to all of their downstream users for transparency's sake. As well as automation. We have cost governance policies, compute policies, serverless budget policies as well. Those can be encoded in Terraform. So even upon the time of infrastructure provisioning, those policies are applied. You can auto-create budgets with account APIs. Every time you create a new workspace, a budget is auto-created as well. And then using Databricks asset bundles to ensure that as you're deploying jobs and pipelines across environments, you're always using the same cost optimized template.
So kind of zooming out on that same thread, in the field, I generally see a gradient and spectrum of kind of two different customer types that try to implement this sort of observability and governance and FinOps management framework. The first one is sort of the monolithic approach. So customers will create a core data platform team that governs and tightly controls all billable objects that go into Databricks. So if a user, a data scientist, analyst, data engineer wants to create a job or a warehouse or a cluster, they then have to file a ticket, go through some rigid process to do that, and then get that cluster created by the data platform team. This is really great because it has generally 100% categorization out of the box. So out of the box, you have instant visibility into spend, but this can very quickly bottleneck your teams. And it requires sort of more technical expertise, more process overhead by not just your core data platform team, but all of your downstream teams that have to know the system required to comply with it. What we see more recently, especially as the modern data stack and the data mesh concepts gain in popularity, is this sort of federated approach, where you still have a data platform team or a FinOps team that's responsible for managing spend, but instead of gating everything, this team creates a single policy layer. Maybe it's very thin layer, just a couple standard set of tags to use that all billable objects need, and then they federate down the how to the remaining teams. So all of the different data teams can use whatever process they want to create, manage, deploy clusters, jobs, and as long as they have the appropriate tags, then that usage is great. And then all the data platform team needs to do is create a monitoring and alerting system on top of that then either deletes the billable objects that are not compliant, or this is the most popular option, is to create an observability framework that identifies untagged usage or mistagged usage that we just showed in the dashboard. You can simply schedule that as an alert, automate that in Databricks SQL natively, and maybe give some of those users, owners of that usage, a week, a couple days to fix that and get it into policy, or maybe justify the spend. So kind of building that framework up in a more federated way lets these data teams that are downstream run quite a bit faster and not feel like they have to walk on glass every time they want to add a new use case, but you still get clear visibility. So the downside to that is you may not always get immediate compliance, but you have a very seamless way to find and fix usage that isn't tagged properly. And there's kind of a whole suite in between, but this federated approach has been more popular in the recent trends here. And going to that operate level, so we've found out how to find, fix usage, optimize spend. How do we actually automate that? So we actually have a ton of solution accelerators built by our field teams and our customers to do things like setting up alerts on forecasted spend. So that dashboard that we reviewed, you can actually just pull out those queries, create a Databricks SQL alert, and schedule an alert on any condition. So if you want to identify when forecasted spend increases, maybe more than 20% compared to last week, all you have to do is copy that existing account usage query, schedule it as an alert, and you're good to go. You can automatically get those alerts. Same thing for automatically notifying owners of untagged or mistagged usage. That tag detail table that we looked at the end, you can just make that an alert. You can create an entire monitoring system out of that. And then even do that for team level contributions. And then lastly, for performance. So that warehouse advisor dashboard, those jobs dashboards, all of these you can build alerting systems to identify when jobs or queries are running longer than an SLA, or a warehouse is scaled up for too long. All of these things can be easily pulled out of those dashboards and automated via alerts. And we can provide some cool examples of some of those, especially the SLA monitoring is a very popular solution built by our field. And hopefully you found this helpful. That is the end of our talk.
But thank you so much for joining.
All right, thank you.